you know, every night our brain. हेलो।
सर,
2 मिनट दीजिए, 2 मिनट में लाइव करिए।
लाइव हो गया है, आप ज्वाइन करिए।
हाँ, बस।
सर, हेलो सर। सर, 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 सर स्टार्ट करते हैं। बच्चे आ गए सर? बच्चे बच्चे आ गए? हाँ. So hello everyone. Here I am going to start aldehyde and ketones. So what do you mean by aldehyde and ketone? Please tell me if the audio is okay. Audio is fine to move. Then we'll discuss what do you mean by aldehyde and ketone and how to discuss those topics very easily. Actually, these topics are really simple for our mains and advanced point of view. Even if anyone from NEET batch is also watching, for them it's really beneficial. So, aldehyde and ketones. Acid will keep it aside. We'll keep it aside after this. First, we have to learn aldehyde and ketone. So, please tell if audio is fine. Just one person, just let me know. So aldehyde and ketone are collectively called as carbonyl compounds. Collectively called as carbonyl compounds. What does the characteristic functional group a carbonyl compound has? C double bond O. If that C double bond O is having a hydrogen on one side, that is called as aldehyde. And if that same C double bond O does not have anything on either side, that is called as ketone. So we clearly know what is aldehyde and what is ketone. Very simple. Aldehyde has C double bond O H and ketone does not have. Now the next question, what is the hybridization? What is the hybridization of this carbon? sp2 hybridization. Sir, I will call you back. Carbon has sp2 hybridization. So what do you mean by sp2 hybridization? It would be trigonal planar. Sir, trigonal planar. Trigonal planar means it will not be existing in a linear plane. Okay. So now, what are non-carbonyls? Many times we confuse. What are non-carbonyl? Although they also have C double bond O characteristic, but they are non-carboxylic or non-carbonyl functional group. First is carboxylic acid. Then second one is Cl. How to convert this acid to Cl? You use SOCl2, an important reagent. Then same Cl, if you treat with ammonia, what will happen? You get C double bond O NH2. It is acid amide. Acid amide. What is this one? Acid chloride. And then what else is the next one? Next one is first one is carboxylic acid. Monocarboxylic acid especially. Now how to prepare ester? R C double bond O O R prime. This is ester. And then next thing is acid anhydride. Do you remember when we discussed IPAC naming and functional grouping? Here we got this as acid anhydride. So all these are components, functional groups, but they are not carboxylic carbonyl functional groups. They are acid and acid derivatives. They are non-carbonyls. So our first topic depends upon carbonyl. So any carbonyl you see, it is C double bond O, single bond. Hybridization sp2. 1 sigma 1 pi here sigma sigma. Approximate bond angle will be 120 degree. We know all these informations from the previous classes. Single bond, single bond. We know all the informations from the previous classes. Okay. Now what else, sir? Here I need to tell you about the orbital diagram. Do you know which orbitals will participate from oxygen side? Yes, sir, I know. So carbon, oxygen. First they will form sigma bond. sp2 orbital of carbon and a 2p orbital of oxygen. They will form sigma bond. What about pi bond? Now another 2p orbital of carbon and 2p orbital of oxygen forms pi bond. You know pi bond is a how many lobe overlapping? 4 lobe overlapping. Then remaining 2 sp2 orbital of carbon will form those single bonds. So you know hybrid orbitals will form sigma bonds, whereas pure atomic orbital will form pi bond. Don't count these as two pi bonds. This is a single pi bond only. So here you have to write pi bond is a 4 lobe overlapping. And understanding of this one is important. Now, every organic chapter, may it be alkyl halide, aryl halide, may it be aldehyde, ketone, may it be alcohol, phenol, ether, it starts with introduction. Then you know, we go to its reactivity. Before going to reactivity, we discuss all type of naming, aromatic naming, aliphatic naming, everything else, whatever present in the naming, we discuss all of them. And then apart from that, what else we discuss? Now we discuss about their methods of preparation, physical properties, chemical properties, and uses. So every organic chapter has these outlines. So let me tell you about the outlines before going to the next slide or before teaching anything else. Let me tell you the overall outline of this chapter. First, introduction, which definitely today I'll tell you about the introduction, even naming, and we can start few of the preparation. Then after that, nomenclature. Now, as you have already done first year part, nomenclature thing is not done in detail. Like I will not going to tell you about the rules to do the numbering, functional group, priority, those things you know. But I'll give you some examples and show those rules again so that it will fresh up in your mind. So first thing introduction, second nomenclature, third necessary reaction mechanism and classification if required. For example, here already you know aldehyde ketone. In aldehyde, you will classify as aromatic aliphatic. Similarly, ketones aromatic aliphatic, symmetrical ketone, unsymmetrical ketone. So all those classification. Then method of preparation. Then physical properties. Then chemical reactions. So these are the components of a chapter which we have to follow line by line. Okay. And the last thing which you have to study from NCRT. NCRT or our state board textbook, everything has similar writing, that is uses of aldehyde and ketone. Same thing will follow for the next part, which is acids and acid derivatives. Okay. So now again come back to our favorite carboxylic acid group. What is this carboxylic acid group? Now, sir, C double bond O. Now, here, you know, these two electrons can be attracted toward more electronegative side. So, this is del positive, this is del negative. Del negative is a nucleophilic center. Itself become as nucleophile and attacks to other electrophile. Whereas other nucleophiles will attack to this point. This will become as a electrophilic center. So carbon in carboxylic acid is electrophilic, whereas the oxygen is nucleophilic. What do you mean by electrophile? Electron loving group. And what do you mean by nucleophile? Nucleus loving group. Okay. Done. Now comes the important topic, nomenclature of aldehyde and ketone. Although they are very late in the priority order. Do you remember the functional group priority order? Carboxylic acid, then SO3H, then all other acid derivatives will come, right? Anhydride, ester, acid chloride, then amide, then cyanide, then aldehyde, then ketone, then alcohol, then thiol, then amine, primary, secondary, tertiary amines, and so on. So you see, aldehyde and ketones are way back in the functional group priority order. Aldehyde has more priority than ketone. So now here you see what is the prefix of aldehyde. Prefix is formyl or oxo. What do you mean by formyl? What do you mean by oxo? Two prefixes are there. I will show with perfect examples how when to use what. Then suffix of aldehyde is al or carbaldehyde. Whereas same things for ketone does not have two things. Prefix of ketone is only oxo and suffix of ketone is only one. Now when to use formyl or carbaldehyde? When the aldehyde carbon is not counted in the parent chain. When the aldehyde carbon is not counted in the parent chain. When the aldehyde carbon is not counted in the parent chain, we can use this type of suffixes. Okay? Move. Next. What else is there? Now here we have formaldehyde. What is formaldehyde? The first member of aldehyde series. Formaldehyde is also called as methanol. Formaldehyde is also called as methanol. Apart from that, what is the next member? CH3, C double bond, OH. This is acetaldehyde. What do we call to acetaldehyde? What is the IPAC name? Ethanol. Methanol, ethanol. Then we have the next member in the same homologous series. Do you remember what is a homolog? Propionaldehyde or IUPAC name is propanol. See, this one is the common name and this one is the IUPAC name. Easy. Now, fourth member not required, but fifth carbon one is important. CH3, CH2, 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 C double bond O, H. What is this? Valeraldehyde. Valeraldehyde is the common name. It's an important one. Please note down valeraldehyde. Valeraldehyde is also known as pentanol. Pentanol. Pentanol means 5 carbon aldehyde. Now, there are few more common names which you have to worry. Is crotonaldehyde and acrolein. What is crotonaldehyde and what is acrolein? Let's see. So valeraldehyde important. The next molecule which is important is CH2 double bond CH, C double bond O. acrolein, acrolein. That is prop 2 in 1 al. Aldehyde. So numbering 1, 2, 2 on this and 3 here. 1, 2, 3. Now similarly, if I go to the next concept, next molecule which I have to discuss is this one. CH3, CH double bond CH, C double bond O, H. That is nothing but but 2 in 1 al. Numbering again starts from this one only, and we get first carbon, second carbon, third carbon, fourth carbon. Next molecule which you have to name, 6-member ring, and it has a CHO. Here you have to be very careful. I told you two suffix of aldehyde. What are those two suffix? One is al, another one is carbaldehyde. Here you see, I cannot do numbering in the chain because chain has one carbon, ring has how many carbons? 6 carbons. By mistake, if the chain has 2 carbon, then I can announce the chain as the primary functional group because the chain is having my functional group. But here, as it is a 1 carbon thing, I cannot decide that the chain is a functional group. So I have to go with the ring as my parent chain. Functional group here outside. Now what will be the suffix? The molecule is cyclohexane. There is no double or triple bond. 1 carbaldehyde. Sir, why are you writing carbaldehyde? Important. Because the aldehyde carbon, CHO carbon, is not counted in the parent chain. It should be 7 carbon, but I cannot continuously number in ring and chain. Either I number in ring or I number in chain, depending upon the rules. So as I cannot continuously number, so I have to choose what? Second suffix, that is carbaldehyde. So cyclohexane 1 carbaldehyde is the molecule. Right. Very good. So it's not cyclohexanol. It's not cyclohexanol, my dear. So see the new correct name. Correct name is cyclohexane 1 carbaldehyde. Yeah, I read your answers. Please check. Please check the correct name. Right. Next. So can we go to the next structure, which is gamma methyl valeraldehyde. So already you know the valeraldehyde structure. 5 carbon aldehyde. 1, 2, 3, 4, 5. Now in this, if this 4 position has another methyl group, see, this is your functional carbon. This is your alpha carbon, beta carbon, gamma carbon, delta carbon. So what would be the common name of this one? And can you decide IPAC name of this structure? First common name, IPAC name you can do for this one. Common name is gamma position as methyl. So gamma methyl valeraldehyde. Whereas when I draw the structure for you, that is I need common name for this one. IPAC name you can try later. First, if you see the structure, 1, 2, 3, 4, 5. So 3 position has oxo. And as per common name, this is alpha, beta, gamma, delta. So alpha functional carbon, beta carbon, gamma carbon, delta carbon. So now it can be written as beta oxo, valeraldehyde. beta oxovaldehyde, or what is the other name of this molecule? Now the other name will be, write down, alpha methyl valdehyde, beta oxovaldehyde. This alpha methyl IUPAC name will be 4 methyl pentanal, 4 methyl pentanal, whereas this one will be 3 oxo pentanal, 4 methyl pentanal, 3 oxo pentanal. Now let's go to some aliphatic to aromatic aldehydes. What is the first aromatic aldehyde comes across your mind? What is the first aromatic aldehyde comes across your mind? Can anybody guess? What is the first aromatic aldehyde comes across our mind when we think? Yes, benzene ring is the aromatic ring. And if I attach CHO on benzene ring, that would be the first aromatic aldehyde. Now, what will be the name? First, one student told, sir, you told me the new method, right? If the carbon is not counted, I'll write carbaldehyde. Yes, benzene carbaldehyde. What is the common name of this one? Benzaldehyde. Now, both are both are accepted by IPAC. You can tell benzaldehyde, you can tell benzene carbaldehyde. Now see this structure, same benzene ring, I have CHO and OH. Do you know this common name of this structure? It is 2-hydroxy. Do the numbering 1, 2. 2-hydroxy benzaldehyde, or common name is salicylaldehyde. 2-hydroxybenzaldehyde or salicylaldehyde. Apart from that, there is another important compound directly from your textbook, Nana. This is really important. CH, double bond CH, and then CHO. See, here the chain is the functional group and the ring is a side chain. And what is the side chain name of the benzene ring? If benzene ring is used as side chain, what should be the prefix we use for the side chain of benzene ring? First, let me tell you the common name of this molecule, cinnamaldehyde. This cinnamaldehyde is obtained from cinnamon. Now name it. Name it by using IPAC rules. 3-phenyl, yeah. Third position as phenyl. Okay, sir, I agree it is 3-phenyl. Then how many members are in the parent chain? Na 3. Prop. Is there any double bond? Yes, sir. 2 in and 1 al. So 3-phenyl, prop 2 in, 1 al. Is it? 3-phenyl, prop 2 in, 1 al. This is the structure. Now, you remember toluene? Obviously, sir, I know what is toluene. Benzene ring and CH3. Now, if I attach a aldehyde here, this will be known as orthotolualdehyde. Similarly, if I attach a aldehyde on the meta position, metatolualdehyde. If I attach a aldehyde on the para position, paratolualdehyde. These are common names. What would be the IPAC names? Not 2-methyl benzaldehyde, 3-methyl benzaldehyde, and 4-methyl benzaldehyde. IPAC names are simple. See, what would be the name of this one? Now, ortho, meta, para. If you use IUPAC naming, you replace this orthometapara with numbers. Numbering start from more priority aldehyde. Okay, like this. Next, you have more molecules which you can try. I'll just tell you the common names of those aldehydes. That is CH3, OCH3. Now OCH3, ether, side chain, it is ortho anisaldehyde. You already have studied the previous chapter ether. There is benzene and OCH3. That is nothing but benzene and OCH3 is nothing but anisole. In that anisole, if you put aldehyde, that is anisaldehyde, ortho, meta, as well as para. Ortho, meta, para. Anisole, say anisaldehyde. Okay? Now, let's see what is acetophenone, what is benzophenone. Before going to that, let me tell you about ketones. CH3, C double bond O. This is a symmetrical ketone. But if I write CH3, C double bond C2H5, this is a unsymmetrical ketone. So you see this ketone is acetone. If you write IPAC name 1, 2, 3, propan 2 on. This would be 1, 2, 3, 4. Butan 2 on. But now you see another symmetrical ketone, both side benzene ring. What is the common name? Benzophenone. What is the IUPAC name? Important, important, important. IUPAC name of benzophenone. Who can try? What is the IUPAC name of benzophenone? What is the IUPAC name of benzophenone? Next, another unsymmetrical is acetophenone. If you can write the IUPAC name of benzophenone, you can write the IUPAC name of acetophenone also. Then, what is the common name of benzene ring? CH2, CH3. This is propionephenone. So, anybody got an idea about the IUPAC name of benzophenone? Yes, students, anybody got a clear idea about the IUPAC name of benzophenone? Can you guess what is the IUPAC name of benzophenone? What is the IUPAC name of benzophenone? So only one carbon in the parent chain. This both benzene rings are side chain. 1 comma 1, 1 comma 1, diphenyl. 1 comma 1, diphenyl methanone. Important. Similar way you can solve this one. This is 1 phenyl ethanone, and this is 1 phenyl propanone, and so on. So please see how we are naming these molecules. Propionaldehyde or propionephenone may not be coming in your screen because my picture is hiding that part, right? So I'll be careful. I'll not write anything there on exact position where it is not coming. Okay, I'll be very careful. I'll not write anything there on that specific point from upcoming slide. Yeah, good point. Thank you. So we'll not write anything on this part, especially propionephenone. Propionephenone I'll draw in the next slide again. So it is benzene ring, CH2, CH3, three carbons. Now there is a another important compound. You know furan. In this furan, if a aldehyde functional group is there, that is known as furfural. Common name of this is furfural, which is a aromatic aldehyde. Now, you know phthalic aldehyde. If two aldehyde groups are side by side, this is known as phthalaldehyde. No, it's not MSD, not NEET. Phthalaldehyde. Now, benzene 1,2 dicarbonaldehyde. Don't think that thala is dhoni here. It is just one position, two position. Similar compound we have is phthalic acid. Benzene ring. Both carboxylic acids are side by side, known as phthalic acid. Okay. So lot of compounds have been covered. Just one more compound and we go to preparation. That is CH. Draw this last one. I'll highlight this one. This ketone is important. So what are the types of ketone? Aromatic, aliphatic. Yes. What are the other typing of ketone? That is one is what is the other type of ketone? Now one is aromatic aldehyde. Yes. Aromatic ketone, aliphatic ketone. Aromatic aldehyde, aliphatic aldehyde. What is the other one? Symmetrical ketone. Both sides of the C double bond O is same. And it can be unsymmetrical ketone. So write down this molecule mesityle oxide. Very important molecule, mesityle oxide. Now IPAC numbering starts from right to left. 4, 5. 4 position has methyl, 3 position has double bond, and it is a pentanol. Like 5 carbon ketone, not pentanol, 5 carbon ketone. So as per that you have to do the name. Please write the name of this mesityle oxide and check if you are writing correct or not. Correct IPAC name of mesityle oxide. Next. Let's finally go to the next part. So classification I have roughly told. Any aldehyde or ketone you can classify as aromatic and aldehyde. Aromatic wherever the carbonyl or the aldehyde or ketone is directly attached to aromatic ring. And then aliphatic which is not directly attached to aromatic ring. Got it? Next, for ketone there is another category of classification which is symmetrical ketone and symmetrical ketone and unsymmetrical ketone. These are the two different type or two different ways how to represent aldehyde or ketone or how to classify. So classification not a big thing, not a big deal to worry, or not in exam point of view also they'll not ask. So real questions will start from here. Methods of preparation. Whatever you learnt in few of these previous chapters will be very useful in methods of preparation of aldehyde and ketone. For example, you learnt ozone-lysis, you learnt Kucherov reaction, you learnt Markovnikov addition, you learnt anti-Markovnikov, and a lot of other things. So let's see one by one how they will affect the methods of preparation. So write down methods of preparation. From here, the real part starts. First, sir, from alkene. Do you remember what is a alkene? Yes, you know. You know what is a alkene. Tell me what does exist in an alkene case? What do we have in alkene? Alkene means we have C double bond C. So alkene means we have C double bond C. So listen, how to deal with alkenes. This is which type of alkene? Symmetrical alkene. In this symmetrical alkene, you can do ozonolysis. Sir, actually there are two types of ozonolysis. One which we are going to do is reductive ozonolysis. Where we studied this reductive ozonolysis in alkane chapter. First, O3, ozone. Next, zinc water. Now, in this, do you remember, we have to cut like this, and both sides will get carbonyl. Mechanism is there. Obviously, sir, mechanism is there. Any mechanism is there for ozonolysis. You just have to go to your first year alkene chapter and find out that mechanism. If you cannot, then definitely in the upcoming lectures, again I will discuss about the mechanism of ozonolysis. Okay. So this mechanism is lengthy and takes some time. That's why we are telling you to check it from your previous class. Now, sir, if I want to prepare aldehyde from alkane, I need both side aldehydes. So what starting material I should take for ozonolysis? O3 and Zn zinc water. Find out what would be the product. Now 2 moles of aldehyde. Sir, but if you start with, what would be the product? If I start with O3 and zinc water here, R C double bond O H plus H C double bond O H. Now R C double bond O H H. Here you see what you are going to get, two different products. What would be the product? Sir, I get R C double bond O R. Then what else I get? H C double bond O H. Sir, one side ketone and another side I am getting formaldehyde. Okay, got it. Now let's see one more point, one more question on this. So questions on ozonolysis based. For this, I need to take help from some previous units. Previous units like LiLH4 reduction. Do you remember LiLH4 or reduction? Do you remember LiLH4 or reduction? Next, let us go to the questions of this point and how to solve questions of ozonolysis. Sir, there is a question that they are given a reactant double bond CH2. This double bond CH2 is treated with O3 and ZnO2, ZnH2. What is the product? Now, this is B, this is A. Now, they have given some conditions. This B reacts with LiLH4 to give a secondary alcohol. B reacts with LiLH4, gives C, and that on ZnCl2HCl. Remember ZnCl2HCl, anhydrous, zinc chloride, and HCl. That is Lucas reagent. gives turbidity in minutes. Turbidity in 5 minutes. Minutes means which alcohol? 2D alcohol. Now this A reacts with LiLH4, gives D when treated with Lucas reagent, same Lucas reagent gives turbidity in hours. So for this question, you have to understand Lucas reagent test. Because Lucas reagent test. Now you have different types of alcohols. 1 degree alcohol gives Lucas reagent test in hours. 2 degree alcohol gives Lucas reagent test in minutes. And what is the next thing? Any other alcohol gives Lucas reagent test. Any other alcohol gives Lucas reagent test in 3 degree alcohol gives in seconds, turbidity in seconds. What do you mean by turbidity? Now, color will change the precipitate. It would be a white solution, turbid. It would be white color solution, which is called turbid. Okay, let's go to answering. Now, 5 minutes means this is a 2 degree alcohol. Which one is 2 degree alcohol? C. So 2 degree alcohol means 2 degree alcohol can be prepared from reduction of ketones. See, this acetone will become propan to all. Whereas this part H double bond O in presence of LiLH4 gives us methanol, and methanol becomes precipitate in hours. So D is methanol and C is propan-to-all, whereas A is formaldehyde and B is acetone. So these are the components which we have to check for this particular reaction, my dear students. Quickly check. Then we go to the next slide. One more question for all of you on this topic, but this is homework. You have to think and decide the answer and revert me back. O3, zinc water. So what would be the product? Now A plus B. This product A and B, some conditions are given. If I am treating CH3MgR on A, Grignard reagent, I am getting C, and this C on Lucas reagent, ZnCl2. Do you remember the Grignard reagent attack on aldehyde ketone? This C on Lucas reagent gives D, which is instant turbidity. So try to solve this one. I will not solve. So identify A and B. This exact same model you will find out in your final paper. In your final mains paper, you find out the exact same model of question. So just be careful how to solve these questions and what are the logic behind it, what are the trick behind it, we have to understand. Next, one more very important named reaction I will tell today is Bucherov. So second thing, preparation from alkyne. You know what is alkyne? C, triple bond C. So here I have a very important name reaction, Kucherov's reaction. This Kucherov reaction has a reagent dilute HgSO4 plus dilute H2SO4. Or how else they will show this Kucherov reaction? Now Hg plus 2 in presence of H plus H2. Now what is specialty about Kucherov reaction? Now first it will undergo Markovnikov addition of water followed by ketoenol tautomerism. So let's see what happens on terminal alkynes and then what happens on non-terminal alkynes. So first let us see on any alkyne this bond will break. OH, H. Markovnikov addition of water. What is Markovnikov addition of water? The negative part of the addendum goes to the carbon having less number of hydrogen. So OH will go to the carbon having less number of hydrogen. Now here I have to do ketoenol tautomerism. Ketone form will convert to enol form. How sir? This will go here and this bond will go here and this hydrogen will leave and come back here. See what they are giving? Now they are making hydrogen shift and making an ketone or aldehyde possible. Double bond O CH2 and this. So this ketone is formed by the reaction. Kucherov is also denoted as Hg plus 2 and H2O. That's what I have written below. So here I am erasing this part, which is not visible to you. Okay. Now this is all about Kucherov. Sir, Kucherov mein there are a lot of things to know, lot of things to learn, and solve a lot of questions. So let's go to the next slide and understand more regarding Kucherovs. See at this structure what you have and how to draw the molecule. So here in the Kucherov reaction, first I will solve for a terminal alkyne. What do you mean by terminal alkyne? What do you mean by terminal alkyne? Where the molecule or organic compound ends with the alkene or triple bond. Now treat HgSO4 dilute H2SO4 dilute. Both together you treat. Now what will happen? This bond will break. OH R CH2 OH C double bond CH2. Now here you have to do tautomerism. After tautomerism, what I will form? Double bond O CH3. This is ketoenol. Ketoenol tautomerism, any doubts? Please tell me. We'll explain ketoenol tautomerism in detail if there is any doubt. This bond will go here. This O will remove the H minus and come here. So whatever, the ketoenol tautomerism will help you to make a methyl ketone. You know methyl ketones has a special character to show iodoform test. What is the iodoform test? I2NaOH and the solution will turn yellow. What would be the product? Now sir CHI3 along with the other part will convert to O minus Na plus. So iodine test is a important reaction, very important. Highlight this part. This is iodoform test. Methyl keto formation. Formation of methyl keto. And methyl keto gives us iodoform test. So see, here I am again writing the ketoenol product R CH2 C double bond O CH3. This is my methyl ketone. Forms methyl ketone and for which test? Iodoform test. What is iodoform? Na CHI3. How to get iodoform from methyl ketone? Na treat I2NOH. You have to treat I2NOH to get iodoform from methyl ketone. So methyl ketone is an important molecule to show iodoform. Now if I solve for a non-terminal alkene, in that non-terminal alkene also reaction can proceed. Obviously we'll get aldehyde, we'll get ketone definitely, not aldehyde. So let's see the reaction of a non-terminal alkene. Non-terminal alkyne. See on this non-terminal alkyne how to write R1 C triple bond C R2. Now in this again Kucherov HgSO4 dilute H2SO4 dilute. When you add these two components, what will happen? First this bond will break OH H R1 OH double bond CH R2. Then what would be the product here? I am writing in the upwards. R ketoenol tautomerism C double bond O CHO R2. This is your ketone. Product is again a ketone. Okay. Now if you take two different groups R1 R2, obviously you can clearly see on which side R1, which side R2. So this R1 must be electron donating group. The OH goes to the carbon having the electron donating group. So important. OH goes in the first step. OH goes towards the C triple bond C carbon having electron donating group. Can you tell me the example of few electron donating group you know? What do you mean by electron donating group? Which group will be responsible for R1? Electron donating group means it can be plus M like OH, OCH3, NH2, NHR and so on. Or it can be minus M. Minus M is not a donor. It can be plus H or plus I. Plus H is methyl, ethyl, propyl. Similarly, plus I groups are also similar. But whenever a same group shows plus H and plus I, we consider hyperconjugation as more important or more in the value. Okay. So this is the two important reaction we studied. I have a homework for you. That is, we'll end up with this question as a homework. See all the questions you have to try yourself. Whatever reactions we are learning, we are applying in the form of questions. And that is the strategy to get organic really good. You get some questions in between the reactions and relate those reactions quickly. H2SO4, HgSO4. Name also I am telling because now only I told. Kucherov's reaction. From this we got A. Now this A undergoes tautomerism to form B. This is form or aldehyde form. Then this B reacts with LiAlH4, lithium aluminum hydride, gives C. This B also reacts with KMNO4H plus. You know, lithium aluminum hydride is a reducing agent. KMNO4 is a strong oxidizing agent. You got D. Find ABCD. Note down the question and we continue from here. Tomorrow you have to revise alcohol to aldehyde and ketone. How to convert 1 degree alcohol to aldehyde, 2 degree alcohol to ketone. What are the reagents? PCC, PDC, Jones, Saret, KMNO4, K2Cr2O7, copper 300. So all these oxidizing agents you have to revise and come back. Similarly, you have to revise reducing agents like carboxylic acid. How carboxylic acid to aldehyde ketone we can make. Those reducing agents also you have to revise and come back. So that's all about today's class. See you hopefully tomorrow will join. Sir will tell you when you are joining tomorrow. Thank you.